Okay, right now we are looking at how to use logarithm tables. How to use logarithm tables and in order to solve given questions. We're given this particular question, but before we look into it, let us explain the basics of logarithm tables. If we have maybe maybe they ask us to do something like to evaluate say 50 times 2 divided by 20. Now 50 times 2 is 100. And 100 divided by 20, our answer is supposed to be 5. Yes or no? Yes or no? Can you hear me? Can you hear me?
Sorry, sir, I really need to use the toilet.
Oh, you didn't tell me.
Yes.
You didn't tell me. Let me ask that question again. I said before we look at this particular question, we must explain the rudiments of using this logarithms table. Okay.
Okay.
Now, and I said, let me start from what you already know that at a glance you can even tell your answer. So I now said, if they give us something like to evaluate 50 times 2 divided by 10.
Isn't that 20?
Hold on. I mean, divided by 20, rather. 50 times 2, right? 50 times 2 is 100, right?
Yes.
Then 100 divided by 20 will give us 5. Yes or no?
Yes, sir.
So whatever I will be doing on this logarithms table, my answer, I already have it at the back of my mind that if I use a calculator, I'm going to get 5, right?
Yes, sir.
So let us now see, using this logarithms table, let us see what our answer is going to be. Okay, is that clear?
Yes, sir.
So whenever you're given things like this, the first step is to have a table number, put number on one side and put log on the other side. So that's why we call it number log. Good. So you're going to rule this and like make it in form of a table. The first number given is 50. Is what? 50. So you're going to write 50. When you write your 50, then you're going to develop a character for that 50 here. There's a digit that will be here before you go into the logarithms table to go and check the value of log 50. How will I get this character? Where will it come from? Let me explain. Just look at the 50 and change it to standard form. This will be 5 times 10 raised to power 1. Okay?
Okay, sir.
The power 1 is the character that I'm looking for. We call it integer. So the character is there. The character is there, and that is 1. Yes or no?
Yes, sir.
Good. We're now going to go into this logarithm and check log 50 under 0 because it's just 2 digits. So if you see this is 50 at the bottom here. So log, let me be sure it is log we're checking at the top of this. So it's logarithm. Then 50 is 6990. Okay.
Yes, sir.
In front of 50, there is 6990. So I'm going to say this is 6990. Then the next number I was given is 2. Yes or no?
Yes, sir.
So I'm going to write 2. Then the character for 2 will be 0. Why will it be 0? If I change 2 to standard form, that will be 2 times 10 raised power 0. Okay?
Yes, sir.
And 10 raised power 0 is 1. So 1 times 2 is still 2. So the character for this one is 1. I mean, is 0 because that's the power. Is that clear?
Yes, sir.
So now, if you check your logarithm table, you will not see 2. It starts from 10. Okay?
Yes, sir.
With that, we're going to look for 20 under 0. So log 2 and log 20 will have the same value. So that will be 3010. That's what I'm going to write there. So this will be 3010. Okay,
Yes, sir.
good. So because it is times, I want to say 50 times 2. Okay,
Yes, sir.
50 times 2. Then it means I'm going to add these together, these two values. So 0 plus 0 gives me 0. 1 plus 9 give me 10. I have 1 plus 9 on the next column again, that's under 10. Then this is 6 plus 3 is 9 plus the one I'm bringing, that is 10 again. Then I'm going to have the 1 plus the 1 at the front, that is 2. Okay,
Okay, sir.
good. So that means this gives me 2 points, all of these digits, 000. Then the next thing is the one at the bottom, which is um, 20. So the 20 at the bottom is going to have the character of, because it's also 2 digits, okay?
Okay, sir.
When you change to standard form, it will be 10 raised power 1. So the character is also 1. So I'm going to put it here. Then I will go over and check log 20 under 0. So 20 under 0 is still the same 3010, okay? Right?
Okay, sir.
3010.
Yes, sir.
So now it's like what I added at the top. I'm going to subtract it again now because this one is division. Okay,
Okay, sir.
good. So that means 50 times 2 divided by 20 is going to give us whatever we get here. Now 0 minus 0 is 0. Then 9 minus 10 minus 1 is 9. Then 9, this one will remain 9. 9 minus 0, 9. Then 9 minus 3, 6. Then this one is already 2. Okay. I mean, it's already 1. So 1 minus 1
Yes,
is 0. So that is 0.6990. Okay.
yes, sir.
Now, once I have done that, the next thing for me to do is to take it out of logarithm. We call it anti-logarithm. Is that clear?
Yes, sir.
So we're going to go to anti-logarithm. We will check these numbers that we have here. 69 under 9 difference 0. Let me call it again. We're going to check 69 under 9 difference 0 because of the 4 digits. Any answer we are bringing is going to come as a 0 point whatever we are bringing. Okay,
Okay, sir.
good. So let us go to anti-log. The next page is also logarithm. Then anti-log should be at the, okay, this one's a logarithm of reciprocals. Let me check for anti-log. Maybe it's at the bottom of the page or something. Logarithms of reciprocal also. Okay, yeah, the next page is anti-logarithm. Can you see? Can you see anti-logarithm here?
Yes, sir.
Now, for this anti-logarithm, you will discover that at the beginning of the first tiny column, all of them have points. All of them have points.
Okay,
So
sir.
And that is the essence of the point that I put here. Then the next thing that we want to do is that we want to go for 69. So that is 0.69. So where would this is 0.00 and so on. So at the base here 0.49, then the next page is 0.60 here, then 0.69 is somewhere here. Can you see my mouse? Can you see my mouse?
Yes.
Good. So this is 0.69. Then I move under 9. This is under 0 here. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Under 9 is 5000. Okay.
Okay, sir.
Then it says difference 0. Difference 0. The difference starts from 1 if you see it at the top here. So there's no difference 0. Okay. So
Okay,
what we arrive at there is 5000. Now, this would have been our answer, but because we're taking it out of antelope, whenever you get here, you will add 1 to any digit that is here. Okay, you know we did not consider this digit when we were going, we only consider the 4 digits. Is that clear?
yes, sir.
So 0 plus 1 there gives us 1. That simply implies you will shift your point only once, okay? Then this is
Okay, sir.
5.000. And that means the answer is 5. Is that clear?
Yes, sir.
Again, very quickly, we can try to do 9 divided by 3 using this method too. You know 9 divided by 3 is 3, right?
Yes, sir.
Okay, good. So let's say we want to just, before we round up because of our time, I'm going to send you this note at the end of the class, okay?
Okay,
Then the question above, we're going to do that later, this particular question. So, but at least just to understand the basis of this. So let's say they ask us to like number two and say 9 divided by 3. All we need to do, the answer is 3, fine, but we want to use number and log approach. So using number and log approach, what we have to do is to write those two numbers that were given and try to find the integers. So 9 to standard form, the character is 0 since it's one digit. Then I will go and check log 9, but there's no log 9. So all I can see there under logarithm is log log 10, starting from 10. So if I'm trying to check um, log 9, I'll go for 90. Okay.
okay, sir.
So I'll go for 90. So definitely this starts from log 10. So at the base of this, I have 54. Then on the next page, I should get 90. So if you can see, you will see 90 here as under 9542. Okay. 9542. Is that
Okay,
clear?
sir.
Yeah, good. So,
Yes, sir.
yeah, that is 9542. Then the next one is 3. So, the character is also 0. Is that clear?
Yes, sir.
Good. But here, I'm going to check 30 under 0 because we can't find log 3. So, this will be 30 under 0. If you check 30, that is 4771. So, this will be 4771. But because we are dividing, it will be 9 over 3, which means I'm subtracting this. Is that clear?
Yes, sir.
Remember, we subtracted at the other side. So 2 minus 1 is 1. 14 minus 7 is 7. 14 again minus 7 is 7. Then 8 minus 4 is 4. Is that clear?
Yes, sir.
Then this will be 0. So again, you will discover that this is the same thing as this, right?
Okay, sir.
Good. Then we now have to take it out of logarithm, which is true anti-logarithm. Then we have 0 whatever that gives us. So let us go and check antilog of 47 under 7. This time around, not difference 0, but difference 1. So I have to go for the antilog. Yeah, this is the antilog. I need 47. So 47 should be somewhere down here. Then under 7. So 1, 2, 3, 4, 5, 6, 7. That is 2999. Difference 1 is also 1. Can you see my mouse?
Yes, sir.
So that will be 0.2999. Then the difference 1, we are going to add it, which is 1. So this will give us, this is 0, this is 0, this is 0, this is 3, this is 0. So then, because there's 0 here at the top here, we're going to add 1 to it, like I explained before. Then it means you are shifting your point once, and our answer is going to be 3.000, which is 3. And it proves that 9 divided by 3 is what? 3. Using number line. Is that clear?
Yes, sir.
Okay. I'm going to send you this note, and let me. Okay, don't worry about doing attempting the question, but I'll send you everything anyway. And when we meet next,
Okay.
maybe that will be on Wednesday by God's grace, we will look into it. But
Okay.
one job I have for you is that you should go through this again. Confirm those figures yourself from the logarithm tables. Is that clear?
Yes, sir.
Okay, so that will be it for today.